this is my topic of research. Myself, Dr. Shamik Palit from University of Stirling, Russell Khema campus, United Arab Emirates. I am also uh, serving the role of session chair in ICRES 2024. So this is my topic, securing big data with Hadoop in enterprise information system. So basically, first, I would like to show you the abstract. Because as you know, in today's world, most of the enterprise applications are data-driven applications, and the role of big data is quite significant over there. And as you know, that there are three very important V's associated with big data. That's known as volume, velocity, as well as the variety. And as we know in today's world, that whenever you are dealing with any specific social media platform, we might have a lot of unstructured data, which is coming from video, photos, as well as any specific type of human behavior and social media links. And generally, our main concern how to deal with the big data, which is quite unstructured in nature. So here our main concern of this particular paper is to find out the security concern associated with the big data. Because as I told you that it's huge volume of data generated in every moment. So we will say that how security can be incorporated along with Hadoop, which is another very interesting technology we used for the big data. So coming to the main part, the introduction. So as I already told you that big data is one of the emerging technology in today's world. And there are various concepts associated with big data. And one of the most interesting technologies is Hadoop, which is actually a core platform for structuring the big data. And this particular software framework is actually helping us in various ways to start working with high volume data. As we know that this is a large data set, and it's not that convenient to process the large amount of data set in a traditional computing process. So that's why the idea of Hadoop actually came into information technology to deal with huge amount of data. And generally, this is represented with the help of different type of nodes, because this is one of the concepts we use in distributed system environment, where the data across large volume represented with the help of the node. But here our main interesting part is security. As you can see in this particular image, three components we have considered. One is known as the velocity, the variety of data, and the volume of data. And inside that, you can see the three-dimensional figure where we have the data from audio, video, as well as from web link, various photos, multimedia-related content, which is available in various digital websites. So these are the main part associated with the big data, the three V's associated with the big data. Let's have a look on a quick difference between the traditional data and the big data. And then it will give you more interest in understanding that why big data is so important, and the security is a high concern associated with the big data. So if we consider any traditional data, this is basically it is a structured data, where a big data is generally unstructured data at the same point of time. And the traditional data size is also significantly quite small compared to a big data. And it's very convenient to work with the traditional data, as we know that there are different language models available, and through that we can easily process and retrieve the data, but which is really difficult as the big data is concerned. So the normal system configuration is absolutely fine to manage the traditional data, but whereas you need to have dedicated configuration to process the big data. So that's the basic difference between the traditional data and the big data model. So again, coming to the main part of this particular research work is the Hadoop, which is actually a programming framework, and it's available on internet in free of cost. And basically, it is made on Java technology. So Hadoop generally make use of a master and slave architecture while it starts processing with any particular data. And generally, Hadoop is also having a file system which is known as distributed file systems maintained by Hadoop, which is also known as HDFS. The basic advantage of Hadoop is it is scalable at the same point of time. It is cost effective and fault tolerant and flexible in nature. So as per your requirement, you can make use of HDFS system, because which is obviously having an integral part as long as big data is concerned. So let's explore the problem definition and objective. So as I already told you, security is the most important challenge associated with this large volume of data, with the variety and the velocity. So we need to understand how we can secure the big data. And there are various ways actually we can implement the security associated with the big data. So that's the most important problem definition and objective of this particular type of research work. And we will first see that these are the few components as I have taken over here, that what are the challenges. Followed by that, the heterogeneous data source is very, very important over here. Privacy is a very important concern. At the same point of time, integrating the data from various sources and the security issues associated with the Hadoop. So these are the 5 components associated with the problem definition and objective, the backbone of my research work. So if you see the objective, as I already told you, that when we are looking for any specific data, the most important thing we need to understand that what type of security has been incorporated in that particular data set, so that whenever we start making use of any enterprise data from any particular information system, so we can analyze the data without having any kind of hesitance, because we know that a strong security surveillances has already been incorporated in that particular enterprise data. So this is what exactly is the background behind this particular type of research work, because it's focusing on one very important concern, that's the security associated with any specific big data, as we are working with a very large data set. So managing the data, retrieving the data is quite important while we are talking about a large volume of data. Companies like Yahoo, Google, so they make use of this particular framework called Hadoop. And obviously, the most important part over here, how we can reduce the time of protecting and processing the data in an enterprise information system. So generally, if I consider Hadoop, it consists of a file system called HDFS. It also having one specific engine that's known as the MapReduce engine. So when we are working with the Hadoop, there are 2 components I would like to focus over here. One is basically node app, the HDFS cluster, which generally consists of a name node and the corresponding data node. And as we know that when we're talking about any specific data node, so generally it distributed over the network with the help of different data block, and it's also ensuring the replication of data throughout the cluster. Similarly, like MapReduce is also another very important component of Hadoop. Earlier it was with the Google, but now it is actually a component of Hadoop. And this is also quite significant whenever we are making use of MapReduce along with the idea of HDFS. There is another very important component we use over here called task tracker, which is actually responsible for starting the maps and reduce the job task associated with any specific scenario associated with any Hadoop infrastructure. Like say, for example, whenever I'm using this Hadoop, which is basically a kind of open source Java framework we use for storing and processing different type of data. So the most important thing which we need to understand, how we can process the unstructured information, how to retrieve the enterprise data as per the requirement. So generally, as I told you, that a cluster of Hadoop generally is consist of a master node and several slave nodes. And one master node generally having a data node and the corresponding name node and a specific type of job tracker and the task tracker. Whereas if I consider a slave node, which consists of both task tracker and a data node. Look at this particular architecture, your idea will be more clear about when I'm talking about an Hadoop architecture. So this is my master node and this is my slave node, and this is how the communication has been established. And here we have the task tracker along with the help of the job tracker. Below the dotted line, you can see that there are 2 nodes available. One is called the name node and the data node. So this is the basic architecture of Hadoop, where we start exploring the rule of security, how exactly we can apply security concerns, security implementation in this particular architecture associated with Hadoop. Look at a closer operation of Hadoop architectures. As you can see that we have a client which starts communicating with the corresponding name nodes. And at the same point of time, it can perform two specific operations with the data nodes. As you can see, there are multiple data nodes available over here. And consistently, we can perform read and write operation with the help of this particular architecture. And this is what exactly is the internal architecture associated with Hadoop. Now, the main concern, as I told you, security enhancement. And that's why I have incorporated what are the security threats associated with Hadoop. Like the most important is who is accessing that particular data. So unauthorized access should be completely prevented. And as long as any specific task is concerned, so we need to understand that the task has been completely managed with the help of the authorized node, job tracker, and the corresponding task tracker. So that's what exactly is the security concern associated with any particular Hadoop. So we have already explored what are the threats associated within Hadoop architecture. The moment we start incorporating a level of security, the first thing what we need to understand is the authorization, a proper authorization. Once we are implementing in the existing security architecture of HDFS, then the level of security get enhanced in that particular manner. So we will learn that how the security incorporation, and for that we have considered two projects over here. One is known as Project Reno, another one is the Project Sentry. So basically Project Reno is actually an open source project, and it's providing a protection mechanism in the Hadoop file structure, and it's giving a customized authorization system for a specific cell. So that's why it is basically known as a cell-specific security incorporation, where every cell is having an user access control and the data remain in a cell level security. So that's the main responsibility of this open source project, which is really playing a very significant role in security enhancement. And another one is known as Project Sentry. It's also playing a very important role, like making a very secure SQL framework through that the data can only be accessed using different level of authorization. And this access control is basically figured out with the help of a data administrator. And that's what Project Sentry is playing a very important role to incorporate users in different level of security. The next thing which is very important over here is the data integration and the big data integration, which is actually helping us to incorporate sufficient level of security while we start working with OLAP type of data, which is actually associated with any big data warehouse, and the dynamic data store and linking and merging. That's another very important part. With the help of that, we need to understand how big data basically work whenever infinite number of data from various sources are coming and getting accumulated in periodic interval. So this is the methodology I have used in my research work, which is known as ETL. The full form of ETL is extract it from different source, then transform the data into a readable format, and finally load that particular data. So that's what exactly is the backbone of my research work, and you can see the implementation detail. The most important part is securing the data from any specific remote location, at the same point of time giving an homomorphic variable tags, and we also need to work with the static data. So provable data position is one of the general concept which has been used in the implementation detail of this particular research project. As I can show you over here, the most important part is POR, that's known as the basic proof of retrievability. And this is basically a kind of cryptographic method which can be used for a specific chunk of data which is actually stored in a cloud-based system. And this POR is playing a very important role, which is having two significant phases. The first one is known as the setup phase, and the second is the sequence of verification phase. Next to that, we have another specific technology called HEL, High Level Availability and Integrity Layer. This is also providing sufficient level of security to the data, and data integrity is one of the most important concern with HEL. And here generally we make use of message authentication code, though there are several limitations also available with the help which has been taken care. So if you see the results and analysis, so I have considered various parameters, as you can see, probable data, basic proof of retrievability, health, and PUR, and everywhere I mentioned the advantages and the constraint, because that's what exactly is the most important thing. Like say, for example, if we consider the basic proof of retrievability, so it reduces the client's and CSP overhead of the computation. So system overhead got reduced. That's the greatest advantages of this type of implementation, and minimize the size of data integrity proof by reducing the network bandwidth, where it is also having certain type of constraints which has been taken care. At the same point of time, if we consider the pure-based system, though, this is also another very interesting technique for the client implementation and includes the minimum overhead on the storage. So these are certain things which has been considered, as you can see in the result and the analysis, which is the outcome of security enhancement in the big data, which is not only reducing the overhead, but at the same point of time, it's reducing the storage and making the data more secure. So in summary, I would like to say that these are the two projects, as I have discussed. One is the Project Rhino and Project Sentry, playing a very significant role in the improvement of the security aspect associated with the big data, which is one of the major concern for today's enterprise application. Mostly the applications are data-driven applications, and making the data more safe and secure and fast retrieval with a better access control. So that's what exactly is my paper. Towards the end, I have mentioned the reference. Thank you everyone for listening. If you have any questions, feel free to ask.